Full body attitude stabilizer for wheel-legged quadruped robots. In this work, an attitude controller that uses model-based predictive control techniques is implemented on a quadruped wheel-legged robot. In order to follow the desired trajectory that is provided by the controller, we use a whole-body inverse kinematic solution that considers constraints and 3 different prioritization levels on the task. The controller we are implementing uses as feedback signals only the IMU data and provide a desired angular position at the center of mass level of the robot. This information is then passed to the Open SOT inverse kinematic solver to map from the task space to the joint space the trajectories and allows the robot to perform and cope with an external disturbance. We found that performing wheel-legged locomotion while rejecting the external disturbance increases the overall stability margins of the robot with respect to the cases where only wheel locomotion or only legged locomotion is considered. From the full body inverse kinematics perspective, the 3 priority levels are poor rolling condition, floating base and arms, and finally legs control. It means that the first strategy the robot will use in order to cope with external disturbance will be the poor wheeling locomotion. Afterwards, the robot will use the rest of the full body locomotion in order to cope with the applied disturbance. The ICRA solution uses an inequality hierarchical quadratic problem, and constraints at the joint position, velocity and force level are considered. Simulation results allow us to see how the robot performs under different disturbances in different situations. In the top part of the videos, we can see the performance of the robot under the open loop condition, using only wheel locomotion strategy and using only leg locomotion strategy. In these 3 cases, the robot is not able to cope with the disturbance and it falls. However, when the wheel-legged locomotion strategy is applied, we can see in the down part of the video that the robot is able to cope and compensate for the external disturbance, recovering the initial posture after the disturbance is completely rejected.